Right, good morning guys. So today, 11:20, it's almost Thanksgiving. No, nobody's going anywhere, sorry guys. Okay, today we're talking about exponential equations. Exponential equations. So really what we're going to do is solve for x in the exponent. So we're going to do a couple of different things. The first two at least, we can see that if we can make it the same base, then it's quite easy. Same base. If it's same base, it's quite easy. These both have 5 to the 3x and 5 to the x plus 2. If they have the same base, then what you're really doing is just solving for 3x equals x plus 2. But that only works if it's the same base. In this case, the base is base 5. And then solve for x is easy. Minus x, 2x equals 2, divide by 2, and x is 1. Boom. Easy. In fact, you can plug it in and see 5 to the third and 5 to the third. Sure, x is 1. Now number 2 is also going to be the same base. But what we don't recognize right now, it doesn't look like they're the same base. But with a little bit of being smart, we know this, that 8, little side work, 8 is the same thing as 2 to the third power. And if I do that, then I'll make them both the same base. So let me rewrite my 8 as a 2 to the third power. And once I make them the same base, then really what I'm doing is really solving for 3x plus 2 equals 3. So once you get the same base, and really all you're doing is solving is the exponents, and then I'm going to solve, right? So I'm going to go minus 2, I've got a 3x equals 1, divide by 3, and I get an x equals 1/3, okay? Boom. That's not bad. Now, example 3 is totally different. If you have a calculator, you're going to need a calculator because you're going to need a log button. Your phone will work, but on your cell phone it gets a little tough, okay? Because if you go to your cell phone and you go to your calculator, you can do logs. Come on, turn on me. Come on. Hold on. Come on. Come on, phone. Well, you have a log button. We've looked at it. But I'm going to use a calculator because I have a log button in my calculator. So what we do is this. The reason we take logs is because logs allow us to solve for the exponent. So one of the rules we learned yesterday was if we had log of some base to an exponent, that it brings the exponent down, okay? We learned this rule yesterday, okay? I want to apply that rule. So this is the rule we learned yesterday. And then you end up with x when it comes down. Okay, this is the rule we learned yesterday. So if we take the log of this side, log of both sides, if you take the log of both sides, okay? Take the log of that and the log of that. The reason we do that is then we'll apply this rule. So the exponent will come down because you've got an exponent to an exponent, which means you multiply. So the exponent comes down. So I'm left with x plus 2 because the exponent comes down times the log of 3 equals the log of 5. So what did I do? I took the log of both sides to start off with, which brings the exponent down. Now, x is no longer in the exponent, it's just solve for x, so I'm going to go ahead and solve for x. Now I'm going to get a decimal. I can deal with that. First thing I'll do is I'll divide by log 3. Divide by log 3. And I'm going to use my calculator to do that. So I'm just going to go ahead and go clear. I'm going to go log 5. Show you here log, regular log on your calculator, 5, parentheses. Close your parentheses, divided by log 3. So I get an answer of about 1.465, okay? So I have an x plus 2 equals a 1.465. 1.4 1.65. Okay, and then just solve. Minus 3, minus 3. So subtract 3, and I get an answer of a negative 1.535. Okay, there we go. So what did I have to do? If it's not the same base, I took the log to bring the exponent down, okay? Let's look at number 4. Okay, number 4, let's go ahead and first get rid of the 12. 12 is kind of annoying. Let's get rid of the 12. Let's divide by the 12. Divide by the 12 first. Okay, get rid of the extra numbers first. Divide out the 12. And then I'm going to go, okay, what is 400 divided by 12? And I get an answer of about 33.33, or 33 1/3. So 33.3 repeating equals my e to the 2x, okay? So I just got rid of the 12. Divide by 12, divide by 12. Easy so far. Okay, now, to get the exponent down, I'm going to apply the rule. So I'm going to take the log of both sides, but with the e, I'm going to take the natural log. So I'm going to do ln. Go ln of both sides. Ln of e to the 2x equals ln natural log of 33.3. Okay. Now what happens is it applies a rule. So if we take the log, go back to this, we take the log, brings down the exponent, right? So we take the log, even though it's a natural log, it brings down the exponent. Okay, so bring down the exponent, and the 2x comes down. Okay, now here's why I wanted to do ln. Because, a little side note, and you can check it out on your calculator. There's a little rule that we know that, you ready? Ln of e is always 1. Ln, the natural log of e, is equal to 1. So this becomes 1. You can even try it on a calculator. Don't believe me. Just go ln of e. Ln, check it out. E. Oops. E. Haha. 1. There it is. Ln of e is 1. Okay. So then you really just get 2x equals ln of 33.3, which you can use your calculator on that and divide by 2, right? So I'm just going to go use my calculator. I'm going to go ln, natural log of 33 point up and 33, a bunch of 3's in there. Divide, and then I'll eventually divide by 2, right? Divide by 2, and there's my answer. About a 1.75 x, because I'm going to divide by 2, x equals approximately a 1.753. Okay? Gosh, I wish you guys were in class because it's a hard lesson, but I'll see you on Zoom, okay? Okay, turn the page. Now, log equations. So now I'm going to solve a log equation, but this is not that hard because we're going to change this from log form to exponential form. So if you remember that log base b of some answer is equal to the exponent, it can be changed into some base to the exponent equals the answer. Okay, so I can transform it from log form to exponential form, which is what I'm going to do right here. Okay, and we've talked about this. So I'm going to go 4 to the third. I'm going to change from log form to exponential form. I'm going to go 4, that's my base, to the third power equals 5x. Okay? So then, 4 to the third, sorry, is 64 equals 5x, right? Divide by 5. That's 64 divided by 5. What does that put? 12.8, I think so. Hold on, 64 divided by 5. Yeah, 12.8. What do you know? I can still do math. There it is. All right, now, example 6. Well, these are bases. They're both base 3, right? So it's very similar to what we did here. They got the same bases, right? It's very similar to what we did here. So really what we're really trying to find out is what is 2x plus 4 is equal to 5x minus 3. Because they have the same bases, what we're really trying to do is figure out what is 2x plus 4 is equal to x minus 5, okay? And then that's easy, right? Minus 2x minus 2x. And then I get a 4 equals a 3x minus 3. Let's see, we're going to go plus 3, plus 3. I get a 7 equals a 3x, right? Divide by 3, and I get x equals 7/3, okay? Now, before I do the last problem, there's a couple of things we have to remember. Okay, I'm going to put those little things on the side. Okay, so a couple of rules. All right, you cannot have a log of 0, and you cannot take the log of a negative number. We need to know that. So if our answer ever in a log, if our answer with a log ever makes that happen, we can't use that answer. Okay, so example 7. Knowing that, let's take a look at example 7. So this one's a little bit different. What I have to do is I've got to combine these. I'm going to use the rules I learned yesterday. There's a reason we learned these rules yesterday, because that's a plus. I'm going to bring the two logarithms together as a single log. So I'm going to go log base 2 of, and I'm going to bring these two together. So what I'm going to do is I'm going to bring this x times my x minus 3. I learned this yesterday. So I'm going to bring my x times my x minus 3 equals 2. So I combined it as a single log. Okay, now the next thing I'm going to do is change it from log form to exponential form. So I'm going to go 2 to the 2, okay? Exponential form. Exponential form. I'm going to go 2 to the 2 power. 2 to the 2 power equals x times x minus 3, okay? Now it's just basically doing some algebra, which we should be good at. We're going to get 4, 2 to the 2 equals x squared minus 3x. Looks to me like I might need to factor it. So we bring over the 4, subtract the 4, bring over the 4, it goes 0 equals x squared minus 3x minus 4, right? Factor x and x minus 4 positive 1, right? And if I do my mini equations, I get x equals 4 and x equals negative 1. But I'm going to throw out the negative 1 because you can't do a log of a negative number. In fact, try it. Try a log of negative 1. It won't work. I'll show you. Just, I know you believe me. I know you believe me. But if you try a log of negative 1, that is not, oh yeah, because it's got the I in there. Huh, that's why. See, it has the I. Interesting. I should change my calculator mode so it doesn't give me an I. Okay, anyway, just 4. And that's all I have. Please do the homework. We will have a test on logarithms really soon. Probably by the time we come back from Thanksgiving, we'll have a test on it. So do your homework.